Okay, 4a, or number 4, consider the differential equation. They don't say anything else, they just say consider the differential equation. But as a reminder, what they're giving you is a formula for calculating a rate, or a tangent slope, or an instantaneous rate of change. That's what they're giving us. Therefore, there is another formula which we don't know yet. That other formula can be used to calculate an amount. So that would be over here. And that formula is going to be y equals something. Or you could think of it as being f of x equals something. Whatever this formula is, this formula is considered to be the solution to the differential equation. Or more specifically, this formula is referred to as the particular solution to this differential equation. Now, they haven't asked us to do any of that, but that's just an overview of what they mean by differential equation. So, on the axes provided, sketch a slope field for the given differential equation. This formula calculates the slopes of this formula. So they want us to imagine that we're not looking at the graph of f, but if the graph of f were to pass through this point, what would the slope of f be when f went through that point? That point is 0, 0. So we take the formula for dy dx, and we plug into that formula an x value and a y value, both of 0. That's going to calculate the slope of f at that point if f were to pass through that point. So, zero divided by -1 is 0. So if the graph of f were to pass through this point here, the graph of f would have a slope that would be horizontal as the graph passed through that point. So that's what we draw for the slope field. Now, a slope field problem goes a lot faster if we look for some symmetry here. So I know wherever the y-coordinate is equal to 0, it won't matter the value of the x-coordinate. Well, careful. If x is equal to 1, the denominator of my formula is 0 and I get an undefined slope. That's why they're not asking you to find the slope field at that spot, because we don't know how to draw an undefined slope. I would draw vertical, be my best guess, but actually don't even know that really, because it would be 0 divided by 0. The y value here is 0. And the x value being 1 would make that formula equal to 0 over 0. I don't know what a slope of 0 over 0 is. So that's why they're not asking it. But at this point, this point here, where the y value is still 0, but the x value is 2, that's going to be the same result here. The slope, when the x value is 2 and the y value is 0, that's going to equal 0, which means the slope of f, if f were to pass through this point, the slope of f would be horizontal again. So a slope field is created using the rate formula, but the slope field is a picture of what the amount formula would look like if the amount formula went through specific points. They're not saying the amount formula goes through both this point and this point. They're just saying that if the amount formula went through either of those points, as the formula for f went through those points, that graph would be horizontal. We've got 4 more points to draw. Looking for some symmetry, I would notice that here the x-coordinate is 0 and the y-coordinate changes. So I don't really have to show work, I just have to show the field. So let's see. Here the y-coordinate is 1. So that gets squared. And then the x-coordinate is 0. like that. That's going to be 1 all over negative 1, which is a slope of negative 1. So we have to draw that slope field now. Come over here. And a slope of negative 1 would be precisely like so, where you're going down 1 and over 1. You don't want to draw a line that big. That's not what a slope field looks like. So I draw this. So here are the first two segments I drew for the slope field, and then I add a segment there with a slope of negative 1. Then I would come to this point. The y-coordinate is now 2. The x-coordinate is still 0. That's going to be a slope of negative 4, which means I have to come down 2 and over a half. So that means the slope's got to look like that. So rather steep. So now redrawing those slope fields. Here's my two horizontal slope fields. And I have my slope of negative 1. And then I have my slope of negative 4. When I get to this point, this is the point x equals 2, y equals 1. Plug those in. X equals 2, y equals 1. That will be a slope of exactly positive 1. So that would look like that. This point is at x equal 2, y equal 2. So that will be a y value of 2. And the x value is 2. That's a slope of positive 4. So that's going to look like that. If I check my work, I did a pretty good job on that one. 1 point for the two slanted slopes, 1 point for the two zero slopes, as indicated over here in the scoring guide. 2 total points for the slope field.